Please note that this calculation provides a rough estimation and should not be relied upon for safety purposes. Always consult a professional for proper handling and cleanup of hazardous materials. If the spill is a mixture of water and benzene, you will need to account for the solubility of benzene in water and the partial pressure of benzene in the air above the liquid mixture. The solubility of benzene in water at room temperature is quite low, approximately 1.78 grams L or 1,780 milligrams L. This means that only a small portion of the spilled benzene will dissolve in the water. To estimate the benzene concentration in the air above the water-benzene mixture, you can follow these steps. Determine the mass or volume fraction of benzene in the liquid mixture. This can be calculated if you know the mass or volume of benzene and water in the mixture. Calculate the concentration of benzene in the water phase. Multiply the solubility of benzene in water, 1.78 grams L, by the mass or volume fraction of benzene in the liquid mixture. This will give you an estimate of the concentration of benzene in the water phase. Estimate the partial pressure of benzene in the air above the liquid mixture, P partial. Use Henry's law, which states that the partial pressure of a dissolved gas is proportional to its concentration in the liquid phase. The equation is P partial equals KH C liquid, where KH is the Henry's law constant for benzene, approximately 0.18 atm, and C liquid is the concentration of benzene in the water phase. Note that you may need to convert the units of the concentration and Henry's law constant to be consistent. Determine the volume of the room, 5. Measure the room's dimensions and calculate its volume. 5e equals length x with x height. Apply the ideal gas law. The ideal gas law equation is PV equals nRT, where P is pressure, 5 is volume, N is the number of moles, R is the ideal gas constant, 8.314 joules per mole, K, and T is the temperature in Kelvin. Rearrange the equation to solve for benzene concentration. C equals N5. C equals P partial x5 divided by R xt. Convert the concentration from moles per volume to a more common unit, such as ppm, parts per million, or mgm3. Please note that this calculation provides a rough estimation of benzene concentration in the air and should not be relied upon for safety purposes. Factors such as air movement, ventilation, and room temperature can affect the actual concentration of benzene in the air. Always follow appropriate safety guidelines and consult with experts when dealing with hazardous substances like benzene. With hazardous substances like benzene,